Today we are going to discuss about surface chemistry. Okay?
Yes, sir.
Surface
Yes.
chemistry. Generally in the reactions, reactant is there. Then the reactant, maybe one or two reactants together react in the presence of some catalyst and forming into product. This is a general reaction. So here, what is the importance of surface of the reactants and catalyst? Those things we will discuss here. What is the importance of surface? Means how the surface is deciding the rate of the reaction. Okay, in the last class, last chapter, the reaction, how much faster it can complete, and those kinetics of the chemical reaction we discussed. Today, in this chapter, the reactant surface, how it involves in the rate. What is the importance of the surface in the chemical reaction? Those things we will discuss. Before going to chapter, the simple one information. See, one solid substance is there, then liquid substance is there, and gas substance is there. Okay, here A plus B is forming some product. Here also same A plus B, same components, but these are in the solid phase, liquid phase, and gaseous phase. So where the reaction is taking place faster? In case of solid, or in case of liquid, or in case of gases?
Gas.
Obviously, this rate is more rate compared to others. Why?
More surface area.
Yeah, surface area. If I take the solid, one cube is there. Here the surface area is A cube. Volume, okay, volume of this A cube here. 4 edges. Okay, 6A square is the surface area. It is a cube actually. Cube means 6 faces are there. Each face area is A square. Total 6A square. Right. In case of liquid, what will happen? These are pieces, small pieces are there. Same cube, but small pieces it became. So here extra surface, this extra surface came in between two cubes. See, outside surface, how much it is there in the solid, same. But extra here, this surface extra is this one extra surface. Are you understanding?
Yes, sir.
So whenever extra surface is there, this is the A compound and this is the B compound is there. A and B can react. So from all sides. So example, say the middle one. The middle piece also can react with B in case of liquid, but in case of solid, suppose the middle part is there, that is not at all contact with the B substance, so there is no reaction with B. The B is reacting with only surface molecules, but in case of liquid, the inside also one cube is there. All cubes, small cubes are separate, so the B can react with the outer cube, inside cube also inside, right? So surface area is increasing. This is the surface area is increasing. That's why rate will be increased. In case of gas, what will happen? These are single molecules in case of gas. So each molecule already separated. So if B is there, B also single molecules are there. One molecule and another molecule directly collide and forming a new product. This molecule and this molecule, this molecule and this molecule. So here more collisions are there, more surface area is there, the rate also more. Okay, this is the main surface area. Importance, right? Next. Differentiation in this chapter, few things are there. How the surface area, okay, one point only I explained here. The surface area is increasing, it's okay. If surface area increasing, what will happen? Those things also, each and every point we will discuss in this chapter. Okay, those points are here in this chapter. One more few points: adsorption and absorption we will discuss. Compare the characteristics of chemisorption and physisorption. These are important questions. We have to learn these headings before completing this chapter. Okay, so we should get it. What is adsorption and absorption, differences and definitions? Chemisorption and physisorption. What are the differences? Then draw the graph of Freundlich adsorption isotherm. Classify colloids. What are the colloids and classification of colloids? Then in that nature of interaction, type of particles, learn mechanism of micelles formation, cleansing agent of soap, interpret properties of colloidal solutions such as Brownian moment and Hardy-Schulze rule for coagulation properties. These things we are going to discuss in this chapter, right? So step by step. The first point, adsorption and absorption. You know that English meaning, that is adsorption, and another one is absorption. Absorption. This is the adsorption. Okay, first word. What is the main difference between adsorption and absorption? See, one sponge I am taking. Generally, in the classroom also, suppose board is there, blackboard. Blackboard is there. They are writing with chalk. A, B, C, something. We are writing chemistry. Okay. So this chalk and board, the chalk dust is there on board. The chalk dust is there on the board. Now, is it called adsorption or absorption?
So I don't know the difference.
Okay. According to English meaning only, I'm not asking chemistry. Here
English,
one
absorption is like it something absorbing. Adsorb, I'm not sure.
one more question I will ask, then I will be clear that. One tin bucket is there. In this water is there. In this water, I kept one sponge. Sponge. You know the sponge that is.
Yes, yes.
Yeah, the sponge is there. It is absorbing the water, not sponge. Even the cloth is there, suppose. Cloth or sponge. I completely dipped in the water. Then, is it called adsorption or absorption?
Absorption.
Absorption. The second one, no?
Second one, yes.
Second one. So the difference is here, this one is adsorption. Which one? This one is adsorption. This one is the absorption. Absorption means clearly many activities we observe that the cloth, the paper is wetting in the water. That is absorption. Adsorption is only surface phenomena. Only surface phenomena. The board, if you rough it, then the dust is removing. Okay. The board and the chalk dust, only physical, some bonds are there. It is only surface. If you remove the first layer, then and the second layer, nothing is there. But in case of sponge, if you remove the first layer, in the second layer also water is there. Okay. That is completely dipped in the water, no? The sponge. The upper layer, middle layer, down layer, completely merged in the water. So it is everywhere the water is there. Okay. But in case of adsorption, only surface phenomena. And one more example. Your system is there. Okay, maybe your laptop is there, right? So on the laptop, on the screen, some air is there. Air. Okay, that is adsorbing on surface only. The air is not going into the screen. No?
Yes, sir.
So that is called adsorption. That is called adsorption. So finally conclusion is adsorption is the only surface phenomenon. Absorption is bulk phenomena. This is the bulk. This is the bulk phenomena. It is only surface phenomena. Okay. Right. Once we go to the points. This adsorption. This adsorption again, two types. Physisorption and chemisorption. Okay. First of all, these are only surface phenomena. In that also, I given here examples. The board and chalk. The chalk dust and board. In between chalk dust and board, which type of bonds you are expecting? Physical bonds or chemical bonds?
Physical.
Generally physical bonds. The air and the screen, the laptop screen and air. In between, which type of bonds?
Physical.
Physical bonds. Okay, so this type of adsorption is called physisorption. This type of adsorption is called physisorption. What is the deciding factor there? The bonds between the bonds between these two things. Actually, what are these names here? The chalk dust is there. It is the chalk dust. And here it is the board. So what are these names? These names are, the board is adsorbent. Adsorbent. This one is adsorbate. Two names. Adsorbate, adsorbent. Which one is a bent? The main substance which is adsorbing. The board is adsorbent. The computer screen is adsorbent. Adsorbate is here, air is the adsorbate. Here chalk dust is the adsorbate. Is it clear? If you take one example, then the definitions and those words you can understand easily. Here board is adsorbent. The chalk dust is adsorbate. Air is adsorbate. The computer screen, that is adsorbent. Is it clear?
Yes, sir.
Right. Now, in between the adsorbent and adsorbate, the types of bonds, if those bonds are physical van der Waals forces, that is a physisorption. If a bond, those bonds are chemical bonds, that is chemisorption. Okay. Suppose example, cloth is there. Cloth. A colorful cloth is there. Some design is there on the cloth. The color and cloth. Cloth means actually it is not a color. No? Cloth means some cotton wicks. Cotton is there. On the cotton, some colorful design is there. The color and cotton, in between color and cotton, is it a chemical bond or physical bonds?
Chemical.
100% chemical bond. If it is a physical bond, first of all, we have to know what are the physical bonds also. Do you know physical bond? Physical bonds are just van der Waals forces. Do you know van der Waals forces?
The
Weakest forces in the chemistry. Weakest forces. In between the gas molecule, van der Waals forces are present. Okay. So here color is very sticky. It is completely, even if you wash it also, it won't go. That's why those bonds are chemical bonds, strong bonds, chemical bonds. So this is the chemisorption.
Okay. Yes,
okay.
Sir.
If a van der Waals forces, weak forces are there, that is physisorption. If strong bonds are there, that is chemisorption.
Yes, sir.
Okay. And one more thing, however, it is cloth, then cloth and color. I given the example. So chemisorption is there, as well as here absorption also is there. It is absorption also and adsorption also, both. Why?
For which one,
Cloth,
sir?
the thread, you can cut the cloth, any thread. The inside also color is there. Okay. If it is restricted to only surface, that is perfectly adsorption. If it is going inside also, that is absorption also. Okay. That is it. So all absorptions are adsorptions, I can say. All absorptions are adsorption, but not reverse.
Okay.
Okay, adsorption means only surface. Absorption, surface as well as inside also.
Okay.
Right. So physics option, chemisorption. If we go once, physics option is called physical adsorption. The adsorbed is held surface of adsorbent by weak van der Waals forces. That is called physics option. In case of chemisorption, it is also called chemical adsorption. The forces holding the adsorbate are strong in chemical bonds. That is known as chemisorption, right? Now, desorption. Desorption. What is a desorption? Adsorption, opposite word is desorption. If in this example, the chalk dust is there. Okay, if I am removing this chalk dust, that is only desorption. Okay, in the computer screen, on the computer screen, air is there. Okay, then if the temperature is rising, room temperature it may be, so the air is moving away because kinetic energy increases. So this is the desorption.
Yes.
Okay. Adsorption and desorption. Right. Once you can see the definition also, the process of removing an adsorbed substance from a surface on which it is adsorbed is called desorption. Example, ammonia absorbed by water, water absorbed by anhydrous calcium chloride. So next, sorption. When adsorption and absorption both are takes place simultaneously, that is called sorption. That is sorption. What is the example? I told that color and cloth. Color and cloth. The dye, you can see the example. The dye is adsorbed initially on the surface of cotton fiber, but later the fiber has uniform concentration of the dye throughout. So now we need to remember sorption means what? Sorption means adsorption plus absorption, both. Okay, once again starting. Adsorption, definition is clear, surface phenomena. Absorption, where it is? It will come maybe next page. Okay. Absorption also clear?
Yes.
Right. Now, in the adsorption, two things, physisorption, chemisorption clear?
Yes, sir.
Then desorption and sorption. Desorption means removing, sorption means both. Which one both? AD and AB. Adsorption and absorption.
Yes, sir. Yes.
Right. Now, enthalpy of adsorption. Now, you tell me, I am keeping one solid substance here. some air molecules are adsorbing on this. These are the air molecules. Okay. Now, is it endothermic or exothermic? Don't know. Okay. Air molecules are before adsorbing and after adsorbing. Here before adsorbing, suppose after absorbing here. Okay, this is the air molecule. I am giving A. Right? Now, in which case the A has more energy? A1 or A2? Which molecule has more energy? Before adsorbing and after adsorbing.
Oh, so how can we tell? Like,
See, after adsorbing, the A2 can move here and there.
no.
No. But the first one is moving.
Yes, sir.
So which one has more energy?
First one.
First one. It has more energy because it can move. It is stabilized. It is sticky.
Yes.
Sticked with this some substance. So it is moving means obviously kinetic energy is there, higher temperature is there, more energy is there. So more energy to it is coming to less energy means some energy is releasing.
Yes,
Okay,
sir.
energy releasing means this process comes under exothermic.
Yes, sir.
Right. So either it may be physisorption or chemisorption. These both are comes under exothermic reaction.
Okay.
In the exothermic reaction, some energy releasing. So this energy we are taking as delta H. What is delta H and delta E? Do you know any differences? Sometimes we will see delta H, sometimes we will see delta E.
Delta H is heat. Heat energy.
Okay.
Delta E is enthalpy.
This is the enthalpy.
That is enthalpy.
This is the internal energy. Thermodynamics, internal energy. But what is the main difference? One point at least, main difference. Carbon burning in the presence of oxygen forming carbon dioxide, releasing some energy. Okay, in the open container. It is the nothing but fuel burning, like carbon is burning. Now, is it comes some energy releasing? Suppose 100 kilojoules of energy releasing. Now, is it a delta H or is it delta E?
Delta E.
Why?
No, I'm not sure. So I think delta H. Okay. I don't know.
Right. See, delta H, delta E, only small difference is there. At a constant pressure, if some reaction is carrying on, that is delta H. At constant volume is there, that is delta E. At constant volume, at constant pressure. In the chemistry laboratory, generally, which we are doing the reactions activities in the open containers. Whichever you are doing in the open container means what? 180 atm pressure.
Constant pressure.
At constant pressure. That's why we will mention delta H.
Okay.
Which are takes place in the closed circuit, that like a pressure cooker. In those are comes under delta E. Here the container volume is fixed. You may think, sir, here also container is 50 ml is fixed. No, the solution may increase or decrease. There is no objection here. It can increase also. It is not fixed volume. But in the pressure cooker, it is fixed. Closely packed. At constant volume, if energy releasing, that is delta E. If at constant pressure, energy releasing, that is delta H. In both cases, both are energies only, but condition is different. Right?
Yes.
So now again back. This is adsorption is exothermic energy releasing. Of course, this process takes place at constant pressure. So that is delta H. Delta H means what? Enthalpy. Okay. Now adsorption enthalpy. Now adsorption enthalpy. This adsorption enthalpy. Now adsorption enthalpy means you understood now. When adsorption takes place, some energy releasing, that is only adsorption enthalpy. Okay.
Yes. Yes.
But the thing is here, adsorptions are two types. Okay, here adsorbent is there. So A is adsorbing with some chemical bond. Okay, first physical bond. It is a van der Waals forces. We have here again substance is there. The B is there. Some bonds are there in between adsorbent and that adsorbate. Here chemical bonds are there. Chemical bonds. So here also energy releasing. Here also energy releasing. Now the question is where more energy will be. Here E1 and E2 is there. E1 and E2. What will be the correct answer? E1 equal to E2 or E1 is greater than E2 or E2 is greater than E1. Here weaker forces, here strong forces. What you are expecting? This is the physics option. It is the chemist option. Where the energy will be released more.
Energy released more.
Chemical bonds, because strong bond is there. When strong bond is there, more energy releasing. Here weak bond is there, easily can break up. Okay, so less amount. See, weak bond is there, to break also less energy is there. When strong bond is there, to break more energy required. Simple logic.
Yes, sir.
More energy required. More energy required means while it is forming, more energy releasing.
Yeah. Yes, sir.
Simple logic. More, see, B strong bond, to break the strong bond, more energy required. That means while it is forming, more energy left. That's why it is required more. Here in case of van der Waals forces, weak bond is forming, required also less only. While the A is forming the van der Waals force also, releasing energy also only less. That's why to break this bond also less energy required. Got it? These 2 points. Any confusion is there?
No, sir, I got it.
Right. So our intention is here only this calculating energies. Which energy is more? In generally always chemist option energy is more than physics option energy. So this is the correct option. E2 is more than E1. E2 in the sense here chemist option is more than physics option. Enthalpies. Okay.
Yes,
here
sir.
E2 I written, but it is a delta H. Delta H1 and delta H2 is there. Obviously, delta H2 is higher than delta H1.
Yes, sir.
Now, enthalpy adsorption. Adsorption generally occurs with release in energy. That means it is exothermic in nature. The enthalpy change for the adsorption of 1 mole of an adsorbate on the surface of adsorbent is called enthalpy of heat of adsorption. See, whenever we are giving some statement, so we have to take some fixed amount. Okay, energy to releasing, but if you take more amount, more energy releasing. If you take less amount, less energy releasing. So that's why we have to specify something. Generally in chemistry, always about the substance, we will take 1 mole. Okay, in case of mass, thermodynamics, generally 1 gram we will take. Here we are talking about gas, that's why 1 mole. When 1 mole of an adsorbate on the surface of adsorbent, it is absorbing some energy releasing, that is only the enthalpy or heat of adsorption. Is it clear or any doubt?
It's clear, sir.
Right. Now the difference between adsorption and absorption. Already we discussed. It is a surface phenomena. It is a bulk phenomena. Now, the concentration of the adsorbate at the adsorbent is much more than that in the bulk. Adsorbate material is uniformly distributed throughout the bulk. The concentration is same throughout. You understood this point? Example, sponge is there. If you dip in the water, the outer layer, middle layer, bottom layer, everywhere the water concentration is same.
Yes, sir.
Uniformly distributed. But in case of physisorption, if you take some solid substance, inside it is not going. So only surface, on the surface only. Right. So the first point is clear. Second point, the concentration of the adsorbate at the adsorbent is much more than in the bulk. That means here in the adsorption, the surface, on the surface, adsorbate is more, inside is less. Second point clear?
Yes, sir.
Then third point. See this adsorbent, here liquid is there. Now I am dipping this some stone or some cube in the water. So what will happen here? Initially completely fully empty area is there, empty surface. Okay, so this liquid is adsorbing fast. Okay, whenever this liquid is adsorbing, the surface area is decreasing because this area is completed within 5 seconds. Then surface area only top side. Then whenever it is dipping, the slowly here also it is occupying. Are you getting?
Yes, sir.
So initially completely empty is there. That's why the rate of adsorption is more. But while time is passing, the rate of adsorption is decreasing. What is the reason? The surface area is getting over. Is third point clear?
Yes, sir.
Initially rate of adsorption is very rapid, but it decreases while slowly till equilibrium is attained. But in case
Yes,
of
sir.
absorption occurs with uniform rate. If I take one sponge, okay, on the surface area and inside, this uniformly mixing. Okay. Then example here, water vapors are adsorbed on silica gel. Here water vapors are absorbed by anhydrous calcium chloride. These are the examples given. Okay, up to this table clear?
Yes, sir.
Next. Factors affecting adsorption of gas on solids. Okay, solid substance is there. So how the adsorbate, some gas is there, how it is adsorbing, that is depends on nature of the gas, nature of the adsorbent, specific area of the solid, pressure of the gas, effect of temperature, activation of adsorbent. So these many factors are influencing. Example, if I take iron, I am taking iron here in one container. In another container, platinum I am taking. Okay, here also hydrogen gas is there. Here also hydrogen gas is there. So closed. Now tell me, it is the platinum rod, it is the iron rod. The size is same. Where the hydrogen gas is adsorbing more, in case of platinum or in case of iron?
So like what?
Nickel, platinum, palladium, these are hydrogenating catalysts. Have you remembered this? In the organic chemistry also it came. Even in the electrochemistry
yes.
also it came. Hydrogen electrode.
Yes, sir.
Hydrogen electrode, how we made? Actually, hydrogen is the gas. With the gas, we cannot make any electrode. So in that case, what we did? Platinum wire we took it. The platinum wire is adsorbed hydrogen. Here we took HCl. Hydrogen and H plus. Zinc and
Yes.
zinc rod, zinc sulfate. Like that, zinc ion and zinc is there. Here hydrogen ion and hydrogen is there.
Yes, sir.
So here it was the platinum. So nickel, platinum, palladium. These are the good adsorbents, hydrogenating catalysts. These are. Okay. So I took it in both containers, hydrogen gas. I am taking here platinum. I am taking here iron. So where the hydrogen adsorption is more?
It will be with
In case of?
Platinum.
Obviously. Here more adsorption is there. Here almost no adsorption. So from this, what is our observation and conclusion? Nature of the adsorbent is important. Nature of the adsorbent is also influencing the adsorption. Okay. At the same time, nature of the adsorbate also. Suppose if I am taking here some water. Okay, gas is there, suppose. Okay. Helium gas I am taking. Here also helium gas is taking. So hydrogen gas is strongly adsorbing, but helium gas is not adsorbing. So that means nature of the adsorbate also. These 2 points clear?
Yes, sir.
Adsorbent also, adsorbate also. This depends on both. Next, nature of the gas. And one more here, nature of the gas. See here, hydrogen gas is and helium gas. Okay, differently adsorbing. Suppose if I take water. Here water is there. I am taking here oxygen gas and as well as some carbon dioxide gas. Okay, which gas can, okay, instead of oxygen, I am taking hydrogen gas, right? Here carbon dioxide gas. Which gas can adsorb more in the water? Carbon dioxide.
Hydrogen.
The carbonated drinks.
Yeah.
By increasing the pressure, the carbon dioxide can dissolve more. But hydrogen cannot dissolve. Hydrogen is very difficult. It cannot dissolve.
Okay.
Of course, in the water, hydrogen is there. That is a different thing. I'm talking about extra hydrogen. The extra hydrogen cannot, but carbon dioxide can. So here, nature of the adsorbent, nature of the adsorbate also important. Nature of the adsorbate, nature of the gas, nature of the gas. Okay. So you can see the points, nature of the gas, nature of the adsorbent, Then specific area of the solid. What is specific area of the solid? Generally, here one cube I am taking and another cube also I am taking. This another cube has some rough surface area. This first cube has very smooth surface area. Now tell me where the gas is absorbing more, A and B. Where more gas is absorbing? The smooth one or on the rough one?
So it will be the
Where the surface
rough,
area is more? In
the
A
rough
or in B?
in B.
B surface area is more, so obviously gas also will be more.
Yes, sir.
Okay, more gas absorbing. So the surface area means specific means if I take 1 centimeter area, here more surface is there. If I take here also 1 centimeter, here less surface is there. That is a specific.
Yes, sir.
So specific area of the solid, pressure of the gas. Pressure of the gas. So you can understand easily the cool rings. By applying more pressure, more gas is dissolving. Okay, less pressure, less gas. Then effect of temperature. Effect of temperature, if I increase the temperature, the gas will be adsorbed or dissolved. Desorption takes place or adsorption takes place if I increase the temperature.
We increase temperature.
Simply cooling bottle is there.
Yes, sir.
If you heat that, then what will happen? The gas will be dissolved more or inside gas will go out?
Gas will go out.
Yeah, gas will go out means what? The solubility is less, the adsorption is less.
Yes, sir.
When temperature is rising, adsorption will be less. In the last also, I given one example. In the screen is there. This laptop screen is there. Here some air is there on the screen. Okay, when temperature is rising, these gas molecules going here and there. So the number of gas molecules in front of the screen is less.
Yes, sir.
So that's why whenever higher temperature, at higher temperature, low pressure will be there. At high temperature, low pressure will be there. Why? Because all gas molecule left from that area escaping.
Yes, sir.
Okay, so that is the reason. So temperature also important. When temperature is rising, the gas desorption takes place. So adsorption is decreasing. Okay, this much over. Then activation of adsorbent. Activation of adsorbent. So adsorbent means what? This solid one, which is absorbing this. Okay, so in the chemistry generally activation is required. Activation means to involve in the activity. Some energy required. That is only activation energy. In the chemical kinetics we discussed the A and A reactant is forming into B. Before going to form B, it should cross over some energy barrier that is called activation energy. Okay, so for that activating, we need to supply some energy for A. How much energy? Up to this. What is this level? This difference? That is the activation energy. Okay, here activation of adsorbent. Some molecules, example carbon is there. Example carbon powder. Okay, this carbon powder normally it can absorb some color components in the liquid. But if you activate this carbon, it can absorb more efficiently, almost double activity it can do. Then what is that activation carbon? Activated charcoal, you will say in the chemistry, activated charcoal. What is that activated charcoal? Nothing. The activated charcoal is nothing but highly heated charcoal. When you are heating, whatever any other substances are there in between the carbon and carbon, those will be burned. So the carbon is free now. Full surface area is empty. All surface area is empty. When we are dipping in the water, it can adsorb from all 360 degrees.
Yes,
That carbon is called activated carbon, activated charcoal.
Okay.
Okay. Now,
Yes, sir.
next topic is adsorption isobar. Adsorption means adsorption. Isobar. What is isobar meaning? Isobar, isotherm. Have you heard
Different
that?
atomic number but same atomic mass.
वो isobar नहीं. That is okay. The thermodynamics. Isobar. Bar means generally which unit it is? Bar.
For pressure?
Pressure. Iso means same. Same pressure. At same pressure, the absorption taking place. That time we are drawing a graph. Okay. The plot of extent of adsorption x by m versus temperature at constant pressure. At constant pressure. Isobar means at constant pressure. Isotherm means sometimes it will come here only there. Isotherm means at constant temperature. Isobar, isotherm. Okay. The plot of extent of adsorption versus temperature at constant pressure is called adsorption isobar. The plot extent of adsorption x by m versus pressure at constant temperature is called isotherm. Adsorption isotherm. First of all, these two definitions clear?
Yes, sir.
Now, Freundlich, one scientist, he observed adsorption isotherms. It gives the relation between magnitude of adsorption x by m and pressure at constant temperature. It can be given by mathematical equation. Generally here x by m is there. What is that x by m? See, if I take here same substance, iron I am taking. Here this 1 centimeter cube. Then here I am taking 5 centimeter cube. 5 centimeter cube, one iron piece I am taking. 5 centimeter cube, here 1 centimeter cube. Here that hydrogen, whatever gas is there, suppose NH3 gas is there. The NH3 gas is adsorbing here, how much? It may be 1 gram is adsorbing. In case of iron, how much it can adsorb? The conditions are same, temperature, pressure, everything is same. Here it is a 1 centimeter cube, here it is a 5 centimeter cube, here 1 gram. Here how many grams it will be?
5 gram?
Simple logic is 5 grams. Because conditions are same, the material is same, nature of reactant, nature of adsorbent, nature of adsorbate, both are same. So generally 5 grams. So if I ask you where the adsorption is more means, obviously here. Okay, so but if I ask you iron adsorption how much, then we have to take specific value I have to take. Otherwise, if you take more value, if I take less value, then which is the correct answer? So in that case, what we are doing, x by m I am taking. If you take x by m, the ratio will be same. How you can check it? M means adsorbent mass. Adsorbent mass. X means gas. Adsorbate mass. Adsorbate mass. Same formula you apply in these two cases. What is the gas? 1 upon. What is the mass of the iron? 1 centimeter cube. 1 centimeter cube means it may be 10 grams, suppose. 1 centimeter, 10 grams. 1 by 10 means 0.1. Okay, here 5 centimeter cube means what? It will be 50 grams. Okay, then 5 by 50, that equal again 0.1 only. Are you getting why we are writing x by m? If you write x
Yes.
by m, I can tell directly iron, I can say. Otherwise, if you take iron, smaller amount, if you take smaller adsorption, larger amount, if you take larger adsorption, which adsorption I am talking? Again, confusion. That's why whenever adsorption is there, we will take only x by m. We will take. Okay. This is the adsorption isotherm Freundlich. He observed that x by m value at pressure P. So temperature at 273 degrees Celsius. Okay, that means 0 degrees Celsius. At 0 degrees Celsius, the gas, he took one gas, then he increased the pressure. So X, the amount of gas absorbing more. Okay. After certain time, there is no change. Okay, he increased at higher temperature, then again absorbing more, it's okay. Sorry, temperature decreasing, not increasing. Temperature, you can see 273, 244, 195. When temperature is less, more gas is absorbing. Then after certain time, whatever pressure you increase, the graphical lines goes like this, parallel only. This graph you understood now?
So we're telling like as the pressure increases,
The
it
x
will
by m
become
value increasing.
increasing, and then it becomes
Ah,
constant.
up to this much clear, no?
Yes, sir.
Now, after certain pressure, whatever pressure you will increase, there is no change in the adsorption of gas. Why? Because see, if this much cube is there in this container, some gas is there, I am increasing the pressure. If all surface area is already absorbed by the gas, so if you increase the gas, if you increase the pressure also, where it can absorb? If there is no surface area, no, already surface area is over, occupied by the
Yeah.
gas.
Yes, sir.
Okay. After certain pressure, if you increase the pressure also, there is no use. That's why those gas molecules are not absorbing. So up to certain pressure only, it is increasing. So at the same time, he observed one more thing. If you decrease the temperature, the amount of gas is more. Why? Because kinetic energy is less. If you take low temperature, kinetic energy is less. Those gas molecules are sticking on the surface of adsorbent. If you increase the temperature, what will happen? Those molecules are moving here and there. So those are leaving the surface. So 2 points have you understood? One is after certain pressure, there is no change. The second point is if you increase the temperature, adsorption is decreasing. If you decrease the temperature, adsorption is increasing. Got it?
Yes, sir.
So x
Yes.
by m is inversely proportional to the temperature, nothing but. Okay.
Yes. Yes, sir.
Okay, I think you have the class.
Yeah, I have the next class in 5
Okay.
minutes.
Tomorrow we can continue from this.
Okay, sir.
Okay, bye.
Bye, sir. Thank you.